Hi, let's talk about polygons. First off, what is a polygon? A polygon has to meet three characteristics in order to be classified as a polygon. It needs to be a closed shape, it needs to be made up of line segments, there are no curved edges, and it must be 2D. Let's talk about each of those for just a second so we understand what each of those mean. A closed shape means that a shape starts and ends at the same point. If you look here, you can see that this shape starts here. When I trace around it, it ends at the same point, so it is a closed shape. The second object starts here, and if I trace around it, it ends here. It starts and ends at two different points, so it is called an open shape. It also needs to be made up of line segments or straight lines. So if we look at this first example, you can see that it is made up of three straight line segments. The next example is made up of curved edges. Because the edges are curved and not straight lines, it is not considered a polygon. The third qualification is that it needs to be two-dimensional or a plane shape. So if you look here, you can see that this is a two-dimensional shape. It's flat. This is a three-dimensional shape, so it would not be considered a polygon. These shapes have a special name that you'll learn later. So let's talk about some examples and non-examples of what a polygon is. If you look at example A, you can see that it has curved edges, so it would not be a polygon. If you look at example B, you can see that it's an open shape, so it is not a polygon. It also has curved edges. If you look at example C, you can see that it has line segments. It is a closed shape because it starts and stops at the same point, and it is also 2D, so it has all three characteristics of a polygon. So this would be a polygon. Example D, it's a closed shape. It also is a plane shape, and it has two line segments, but it also includes two curved edges. Because there are curved edges, it is not a polygon. So let's see if we can classify these shapes. Is shape A a polygon? Well, let's see if it meets all three of the characteristics. It needs to be 2D, it needs to have line segments, and it needs to be a closed shape. Remember, it has to have all three of those characteristics to be considered a polygon. So we can look at this and see, yes, it's a flat shape. It is 2D. Check. Does it have line segments? Yes, it does. Check. And is it closed? Yes. So this is a polygon. If we look at B, we can say, is it 2D? Yes. Does it have line segments? No, it has curved edges. It is not a polygon. Let's look at C. Is it 2D? Yes. Does it have line segments? Yes, it does. And is it a closed shape? Does it stop and start at the same point? Yes. So C is a polygon. Let's look at D. Is it 2D? Well, yes, it is. Does it have line segments? Yes, it does. But does it stop and start at the same point? No. It is an open shape, not a closed shape, so it is not a polygon. And let's look at E. Is it 2D? Yes. Does it have line segments? Yes. And is it a closed shape? Does it stop and start at the same point? Yes. Because it meets all three of those characteristics, it is considered a polygon. We can name polygons or classify them based on their sides, angles, and vertices. If you look here, we can see different types of polygons. Let's look at their characteristics and why they have the names that they have. This triangle has three sides. It also has three angles. It also has three vertices. Because it has three sides, three angles, and three vertices, we call that a triangle. Tri means three. The next shape is a quadrilateral. It has four sides. It has four angles, and it has four vertices. Because it has four sides, four angles, and four vertices, we call this a quadrilateral. Quad meaning four. The next shape is a pentagon. It has five sides, 5 angles, 2, 3, 4, 5, and 5 vertices. We call this a pentagon. Penta meaning 5. The next shape is a hexagon. We can count its sides, angles, and vertices to see why it's called a hexagon. Here we go. We have 1, 2, 3, 4, 5, 6 sides. We have 1, 2, 3, 4, 5, 6 angles. And we have 6 vertices. So you guessed it, hexa means 6. The next shape is a heptagon. It has 7 sides. 1, 2, 3, 4, 5, 6, 7. 7 angles. 1, 2, 3, 4, 5, 6, 7. And 7 vertices. Whoops, 1, 2, 3, 4, 5, 6, 7. Hepta means 7. Octagon means 8. We have 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. 8 angles. And 8 vertices. Octa means 8. Nonagon has, well, it doesn't tell us, so let's count them. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, which means it also has 9 angles and 9 vertices. And a decagon has 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides, 10 angles, 7, 8, 9, 10, and 10 vertices. If a shape has 10 angles, 10 sides, 10 vertices, it is called a decagon. Deca meaning 10. Nona meaning 9. So as you can see, as you look at these polygons, if you're given the name of a polygon and it's a pentagon, you will know that it has 5 sides, 5 angles, and 5 vertices. So let's see if we can name some of these polygons. Here's a yield sign. I bet you see this when you're driving with your parents. Let's see how many sides, angles, and vertices this object has, because that will help us name it. There are 1, 2, 3 sides. There are 1, 2, 3 angles. And there are 1, 2, 3 vertices. Because this shape has 3 sides, 3 angles, and 3 vertices, we would call it a triangle. Let's see if we can name this polygon. Remember, in order to name a polygon, we need to look at its sides, its angles, and its vertices. So let's count. We have 1, 2, 3, 4, 5 sides. We have 1, 2, 3, 4, 5 angles. And we have 1, 2, 3, 4, 5 vertices. Because this shape has 5 sides, 5 angles, and 5 vertices, we would call it a pentagon. Let's see if we can name this shape. Remember, we look at sides, angles, and vertices. Let's count the sides. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 angles. And 2, 3, 4, 5, 6, 7, 8, keep erasing, 9, and 10 vertices. Because this shape has 10 sides, 10 angles, and 10 vertices, we call it a decagon. You might be wondering why it's important for students to be able to name polygons. If you think about it, our world is filled with polygons. Sports courts, buildings, art, homes, schools, all consist of polygons and shapes. It's important for students to be able to identify them correctly. It's also a foundational math skill. It helps students develop their analytical thinking to be able to identify the characteristics of shapes and name them based on their sides, angles, vertices, and other characteristics.